Hey guys, welcome to 7.4. It's combination and probability. Today we're going to talk about students will be able to use combination to find probability when it involves large counting numbers. So, since many probability problems involve counting, it is natural that combination could be used to find probabilities where the counting becomes very large. So, let's look at our first example here. Consider a classroom containing 18 girls and 12 boys. A teacher would like to form a four-person committee from these students, where the order in which she chooses the students to be on the committee does not matter. So the order does not matter means I'm dealing with combination. How many different ways can the teacher create a four-person group? So there are 18 girls and 12 boys. So the total here is 20. So I want to choose a four-person committee. So a combination, the total is 20, and I want to choose 4. So it'll be 20 choose 4. And if you put this in a calculator, you should get 27,405. Now part B said, how many different ways can the teacher create a four-person committee if it only has girls? So now there are 18 girls and we need to choose 4. And this will give me 3,060. C says, what is the probability that the committee that is randomly selected could contain only girls? So remember what we said, probability, earlier we talked about probability, is the possible outcome over total outcome. So we're talking about choosing only girls. So the probability of girls, we saw that it was 3,060 over, if in total, which is our 20 people in total, the total probability of that is 27,405. You can leave it at this or just simplify it to 68 over 609, which you can do on your calculator. Now the last one says, what is the probability that a committee that is randomly selected would contain 2 girls and 2 boys? So 2 girls and 2 boys. Remember, we talked about "and" earlier means to multiply. So 2 girls would be 18 choose 2 times, how many boys do we had? We had 12 boys times 12 choose 2. This will work out to be 153 times 66, which is a total of 10,098. Now the question said, what's the probability here? So again, the probability is your possible outcome, which is 10,098, over your total outcome, which is, what if we had that 20 people from part A? This becomes 27,405, or you can simplify if you want to 374 over 1015. So the thing is, by applying the fundamental definition of probability, combination can help us greatly in terms of finding probability in situation when it's too difficult or time consuming to count. Because we could have done this, but then will we be able to count 27,405 possibility? That's way too much. Now let's take a look at this. It says Adriana is trying to choose 5 DVDs to take on her vacation. She is selecting from 6 action movies, 8 comedies, and 4 dramas. If she randomly selects the 5, find the probability that she choose 5 comedies. So, again, when you think of probability, you want to think of total outcome. So let's see. She has 8 comedies. I think I missed 6 action. And then she has 4 drama. So in total here, there are 18. Okay, so there are 18 DVDs that she needs to choose from. So we want to find the probability that she will choose 5. Is that what she's looking at? She's trying to carry 5 DVD on her vacation. So the probability are 18 DVDs and her choosing 5. Let's get rid of this. Her choosing 5 will give us 8,568. Now this is the probability in total. This is our total possible outcome. Now it says what is the probability that she choose 5 comedies. So how many comedies we have? Perfect. We have 8 comedies. So now we need to see 8 choose 5, which is 56. So the probability is their possible outcome, which is 56 over your total outcome, which is 8,568, or if you want to simplify this, it doesn't matter, 1 over 153. Okay, now let's just separate that off. It says what if she choose 2 action, 2 comedies, and 1 drama? So again, we know the total possibility as we calculated was C 18,5, which is the 8,568. So 2 action. Let's break this up. She has 2 action, 2 comedy, and that's my keyword, and 1, make it fit here, drama. 2 action, a total of how many actions she had. There are 6 actions. She wants to choose 2. Comedies, there are 8 comedies. She's choosing 2. And in drama, there's 4 dramas. She's choosing 1. If I was to multiply this out, I get 15 times 28 times 4, which will give me 1680. So therefore, the probability would be 1680 over the total up here, which is 8,568. You can go ahead and simplify this to 10 over 51. It doesn't matter. Either one is correct if they didn't say to simplify. So let me just box these answers off. So again, why did I multiply over here? Because my keyword here is and. Remember, and means multiplication and or means addition. Okay, let's move on to exercise 3. So in the last 2 lessons, you truly learned that you need to know how to calculate probability in this lesson. So all we're going to do is here is about calculating probability. Now let's look at exercise 3. A very old florist is making random arrangement of 6 flowers. He has 8 tulips, 12 roses, 6 daisies to choose from. Determine the total number of ways to select 6 flowers from the florist's 26. So this is the easy one. There are 26 and he's choosing 6. So 26 choose 6 is 230,230. That's it. That's the easy one. Now B says, if the flowers are chosen at random, what is the probability they're all roses? So again, he has to choose 6. So this is my total probability. It says, what is the probability that they will all be roses? So first, let's see what if they're all roses. How many roses do we have? Back here. Roses, roses. There are 12. And remember, he's making a 6-flower arrangement. So it will be 12 choose 6, which will give you 924. Now the probability of this would be the possible outcome, which is a 924, out of the total, which we calculate in part A as 230,230. And this will be my final answer. Now what it says, what if the flowers are chosen at random? What are the probability that there are 2 of each? So I gotta get 2 tulips. I want to get 2 roses and 2 daisies. So tulips. We have 8, so we need 8 choose 2. And remember, and means we multiply. There are 12 roses, and we only need 2. And then there are 6 daisies, we need 2. Now looking at this, we get 28 times 66 times 15, which will give me 27,720. Now, the probability, now let's just switch color because I'm running out of space. The probability that this will happen would be, well, we just calculated the probability of getting 2 of each over the probability of the total outcome, which is what we calculated in part A. And this will be my final answer. Let's just mark that off there so we get some space. Now, looking at part D, it says, if a flower is chosen at random, what is the probability that they're all going to be tulips or all daisies? So there are 8 of this, so we need to find the probability of 8 choose 6 plus, because I'm dealing with or, and there are 6 daisies, 6 choose 6. This is actually going to equal to 28 plus 1, which is 29. So therefore, the probability would be 29 out of my total, which goes back to part A, 230,230, and this would be my final answer. So for questions like these, you have to know what's the total possibility of something happening, which is always my denominator, and then we need to look at what credentials were being asked. So like in part B, over here in part B, we were asked what if they were all roses. So we need to know what's the probability, what's the combination, how many different ways can it all be roses. Here we were asking for 2 of each. And then in D, we were asking what if they're all tulips or daisies. So once you know what the possibilities are, what we're looking for, we can calculate that. Now let's see what it looks like on the regions. I have 4 and 5, multiple choice. Franklin has 5 quarters in his pocket, 2 nickels, and 3 times. And 3 dimes. If he pulls out 2 coins at random, what is the probability that he will have 50 cents in his hand? Again, Franklin has 5 quarters in his pocket, 2 nickels, and 3 dimes. This should be dimes, not times. This here. This should be dimes. If he pulls out 2 coins at random, what is the probability that he will have 50 cents in his hand? So now you need to think. You have 5 quarters, 2 nickel, and 3 dimes. How is it that I can pull 2 coins out to get 50 cents? I know the only way that I can do that is by getting what? Pulling out what? 2 quarters. Excellent. So I need to find what's the probability if I pull out 2 quarter. 2 quarters, the probability of me pulling 2 quarter, not a probability, different ways, is 10 ways that I can do that. Now what's the total probability? There are 10 coins in his pocket, and I want to choose how many? 2. So this will be 45. And then, so now we were asked to find the probabilities of possible outcome, which is 10 ways, over the total possibility, which is 10 over 45, which can also be simplified to 2 over 9, which is choice 4. How do you simplify this answer here? Just put it in your calculator. Control division, 10 at the top, 45 at the bottom, and hit enter. Exercise 5. Harold draws 5 marbles out of a bag that contain 12 red and 10 blue. Which of the following would calculate the probability that Harold draws out 3 red and 2 blues? Now automatically you know and means multiplication. So I can look at this and automatically tell my answer is choice 2. But let's see why. The probability of getting 3 red and 2 blue. So what is this? This is probability. There are 12 red. I need 3 of those times there are 10 blue, and I need 2 of those over what's the possible outcome. There are a total of 22, and I'm choosing 5. So by not even doing anything, you know that and, this word right here, and means multiplication. The only one that has multiplication is choice 2. Now the last example before we go to practice problem. Mr. Jim Shorts is trying to form a 6-person volleyball team for his 9th grade physical education class, which consists of 10 girls and 14 boys. If he picks a team at random to the nearest percent, what is the probability that the team will consist of all girls or all boys? So, keyword or means I add. Probability of getting all girls. How many girls are on this team? So it will be 10, choose 6, because he wants to get a 6-person team, plus there are 14 boys and we're choosing 6, over, what's the possibility here? What is the total of the 2? There are 24 of them and I'm choosing 6. If I was to work this out, I get 210 plus 3003. Sorry for the pause, I'm working these out as we go along. And then the total outcome is 134,596. Now it says to the nearest percent. That's my keyword. So that means I need to simplify this. This is actually 3213 over 134596, and I want to multiply this by 100 because they asked me for percent. So this is actually going to be approximately 2%. It actually works out to be 2.387, and it keeps going. So to the nearest percent will be 2%, which is choice number 2. Alrighty guys, I know this has been a long video and a long unit, but we're actually halfway through this. Now, go ahead, practice those questions, and see me when you're ready for mastery. See ya!